Good day to you viewers and welcome to another video. I hope everything is good and well with you all so far. And I just want to say thanks to those of you who have watched my previous videos. I am really appreciative of it, and it will only serve as an encouragement to me to do more videos like this to educate and inform you where building construction is concerned. And in this video, I'm going to be taking you through how to read and understand a set of working drawings, otherwise known as building drawings or blueprints. I hope you find this video very informative, and if you like the video, please hit the like button, share, comment, and subscribe. So without further ado, let's get into the video. Thanks. Presentation is going to be taking you through how to read a set of working drawings, otherwise known as blueprints. So the first thing you have to differentiate when you're reading a set of plans is what is the plan view as against what is the elevation view. Now, your plan view is looking down from above on your building or having a bird's eye view of the building. It's as if you're up at a certain elevation above looking down. So whenever time you come across the word plan on your set of blueprints, it just means that you're looking down. You're looking down on the structure or you're looking down. And elevation now is where you're looking directly on the erected building. Okay? When the building is fully erected out of the foundation up to your roof height. So your elevation is just looking at the erected structure or you're looking at the structure dead on. Okay? Now, there are different types of drawing in a set of plans. Okay? There's a civil drawings where you're talking about your utilities, your grading, your plot plan. In the case of a residential building, you could consider your site plan as a part of your civil drawings. Then there's the architectural drawings, which deals with the floor plan, elevations, and details. There's the structural drawings, which deals with the foundation plans, beams, columns, slabs, etc. There's a mechanical that deals with the ductwork, the equipment, the detail, the electrical plan, which deals with the power, lighting, panel schedules and detail, and there's a plumbing plan which deals with wastewater, water supplies, and equipment. But let me make this distinction that when we're talking about a residential building, we are not so much speaking about the mechanical and the electrical. Okay? We do an electrical layout or a plumbing layout. Now, this is entirely different from your mechanical plan, from your electrical plan, and from your plumbing plan. These are mainly for industrial building or commercial building, where the magnitude of construction is vast, more detailed. Okay, but for the typical residential building, you do not have to consider mechanical and electrical and plumbing plan. These are for bigger industrial building. We just merely talks about or deals with on the working drawings, your electrical or your plumbing layout. Okay, now your line types. Okay, you have to be able to understand and interpret what the different line type is, because without you knowing this, you're not going to be able to know what that line is communicating to you. Okay, so the first one we have here is your object line, and your object line, these are solid lines. Okay. Then we have hidden lines. These are broken lines. Okay. Then there is center line, which there is one line, one short line, a dash, and a short line, and so forth and so on. Okay. Then there's a property and boundary line where there's one dash and two small dash in between. So whenever time you take up a set of building plans and you see this line, you must be able to know what those lines are communicating to you. Okay. Then we're talking about line weight. Now, line weight is very, very essential in interpreting what the drawing is, what the drawing, that aspect of the drawing is communicating to you. So there are solid lines are used to, there are solid thick lines that are used to communicate depth, importance, and relative proximity. Now, let me explain that a little bit further. Now, when you see a thick line, okay, that just means that the object is closer to you, okay? When the lines are thin, that means the object is further away from you, okay? So that's all that is. Your line weight just tells you what is closer, you know what I mean, as against what is receding in the backward, in the foreground of your building plan. So that is critical to know. Okay, we are talking about text now, and text. Well, this have some level of importance, but from what I've seen, I mostly see text play a critical part when I'm talking about like bridge. When I'm looking at a bridge design plan, your typical residential plan, I don't see much emphasis placed on text, but text do play a critical part in communicating aspects of the drawing as well. So when you see a portion or a part of your building or a part of your structure that is written in italics, that is basically telling you that that portion or that part of your structure or your building is existing. Okay. And when you see text that is written in a normal way, you know what I mean, the normal text writing, that is generally for what is proposed. So that is really all where text is concerned. But just be mindful that when you see something written in italics, it is mean that it was existing prior to the proposed structure being built. Now we are talking about abbreviation now, and this is very, very critical. Okay, because to be familiar with the drawing, you have to know what most abbreviation is or are, because not everything is going to be spelled out on the drawing for you to read and understand. So these are some of the regular abbreviation on the plan that you have to be familiar with. Yeah, whenever time you see FFL, it means finished flow level. GL, that means ground line. CMU, construction masonry units. For example, your concrete blocks, your bricks, etc. MSB, your mild steel bars. OC means uncenters. CRS, centers. MPa means megapascal in metric. You know what I mean? The unit for measuring pressure in metric is megapascal. And sometimes you might see on the drawings Newton per millimeter square or Newton per meter square. It means the same thing. It means Pascal. Then on another time you see in the imperial system, if the drawings is done in an imperial, like here in the United States, much of the drawings is done in imperial. You will much more see pounds per square inch or psi. So that's the imperial representation for pressure. Then you have MH, which is manhole, and GB, your gully basin, and GT, grease trap. So just be familiar with these abbreviations, and whenever time you see them on your drawings, you know exactly what they are speaking about. So that pretty much sums up this part of my presentation where reading, building, drawing, or blueprint drawing is concerned, I'm going to be taking you through a actual set of drawings where you can physically see these things applied to the drawings, and then you can make a better connection or a better understanding of what I'm talking about. Okay? Welcome to this segment, and as you can see here in my picture here, this is the site plan, okay, of your proposed building. So the site plan, most of the time when you take up a set of building drawings or a set of working drawings, is always going to be your first sheet of drawings. The first thing you look at when you take up a set of drawings is going to be your your site plan. Okay. Some architects or draftsmen they comes up with a separate cover sheet, but in most cases, you can just incorporate your site plan with your cover sheet. So your site plan most of the time is going to be your first sheet. So as you can see here, this is what the site plan actually looks like. Okay. Now, the main purpose of the site plan is to show or to demonstrate the setting out of your proposed building on your site. Okay. So your building on your site must be set out in such a way that it is in conformance with the covenants of the land and also with the local planning authority. So the site plan really is having a bird's eye view of your building as it is set out on your site. It's as if you're at a higher elevation looking down. And as the word suggests, and in my last PowerPoint presentation, I told you when you see the word plan, it means that you're looking down. So your site plan is actually you're looking down on your site. Okay. So your site plan, it also shows um existing features of the land. You know what I mean? It can show existing trees, it can show your easement, it can show essential things on the site that you want to keep. You know, you don't want to demolish those things. But in the case of this drawing, as you're looking at, in the case of this site plan, you're not going to see this because this land was practically empty. So there was no existing trees or that, you know what I mean, for me to remove. The land was basically empty. So as I said to you before, the most important feature of your site plan is just to show your outline of your proposed building. And if you notice the lines on this drawings here, as it is depicted on the site plan, it is the most thickest. You know, it brings out from the remaining of the drawing. So anyone take up this drawing can look and see that this is the proposed building as you're looking at. So as you can see the relative setbacks. You can observe the relative setback that this building is approximately 45 feet from the center line of your road. Okay, and is approximately, or it is 8 feet from this boundary here, from this property line here. And if you notice my property line, you know what I mean, it is drawn exactly how I presented it to you in the last slides. You know, one line and two small dash. So that represents your boundary line. Okay, and also your site plan also shows your drainage, like your manhole, your gully basin, your septic tank, and your reed bed, your soakaway pit. You know what I mean? So yeah. Also, you must observe most site plan, every site plan should carry a north arrow. It must show north. And this is magnetic north, not true north, magnetic north. So this is the north arrow here. It's showing you the north arrow. Okay? And also you must pay keen attention to the scale of the drawing. You know what I mean? That helps, in terms of if you can't figure out any if the drafts person had left out any important dimension, you can always use a scale to obtain that dimension. You can use your tape measure, and this instance the side plan is drawn at um 1/8 inches equal 1 foot 0 inches, or 1 in 100. Okay, so over on the right hand side of this drawings here is your general notes. Okay, and I can't stress this anymore, but you must always try to read through your general notes very, very thoroughly, because it contains relevant information or pertinent information as it relates to the type of material that is supposed to use, the strength of your material that you're supposed to use, as well as other important aspect as it relates to the drawing. Okay, so that pretty much sums up the site plan. So now we can move to the floor plan. Okay, so yeah. So your floor plan, in my estimation, is the most important part or feature of your building designs or your working drawings, because most of your drawings is going to be derived from your floor plan. Your foundation plan is going to be derived from your floor plan. Your roof plan is going to be derived from your floor plan. Your sections, your elevation, your electrical and plumbing, all of these features is going to be derived from your floor plan. So your floor plan, in my opinion, is the most important aspects of a set of building plan. Okay, and the floor plan is what most contractors use or builders use to line out the building or to set up the building. So the most important observation of your floor plan, you must always check your floor area. Observe where you have your kitchen, your bathroom, your living, your dining. Go through and study your floor plan. Okay, you must also study the dimension, your overall dimension of your floor plan, because it is going to give you the size of the building. Okay, and you must also observe the size of your windows, the size of your doors, and your size of your openings. You know what I mean? You must always observe that, because that is going to be critical for you to build the building as it is outlined on your floor plan, right? So if you notice too, I draw my floor plan with very thick and arch line, very thick, and it is arch. Now, whenever you take up a set of drawings and you see arch, you see the line, inside of the space here is arch. It means that it is cut. Okay, it means that it's cut. And a critical piece of information that I should point out to you where floor plan is concerned is that your floor plan is cut 4 feet above your finished floor level. Always remember that your floor plan is cut 4 feet above your finished floor level. Okay, so when you cut that building 4 feet above your finished floor level, you're looking down. Okay, and you just pretty much draw You just pretty much draw what you see. Okay. You just pretty much draw what you see. So always take that into consideration that your floor plan is called 4 feet above your finished floor level. And my word to you, if you're a builder or a contractor. Another important aspect of your floor plan is you should take into consideration the placement and the location of your stiffener columns. And especially if you're the builder or the contractor, you need to pay key attention to this because your stiffener columns is placed at the corner of your buildings or at walls intersection or where you need to break the span of a wall. Okay, and the function of your stiffener column is to resist shear forces, okay, or shear movements, okay, due to lateral movements, due to earthquakes, okay. And also the stiffener column is placed strategically at these locations also to prevent the building from moving when you have differential settlements in your soil. Okay, so the stiffener column will limit the amount of cracks, structural or flexural cracks that you will get in your building when you have shear movement or shear forces or differential settlements in your soil. So it is critically important that you pay keen attention as a builder or contractor your location and your placement of your stiffeners. Okay, and another thing that is of note where the floor plan is concerned is your section symbol. Okay, you know what I mean. This is if you can see this the cursor going around this symbol here. This represents your section cuts and the direction in which the triangle is point is the direction that you're viewing or you're seeing when you actually do the section cut. Okay, and if you notice it is labeled section AA. Okay, so observe that while you are doing your building, and if you're the one that is responsible to construct this building, these are things that you should look out for when you're doing your building using your floor plan. As I said before, it is the most critical component of your building and you should pay much attention to it. Another small part of the floor plan I should mention is your scale. Okay, if you notice in this floor plan in particular, it is done at a scale of 1 in 50 equal quarter inch equal 1 foot 0 inches. Okay, and what that means is that every quarter inch on your tape measure represents 1 foot 0 inches. So in the event that a critical dimension is left off the drawings, you can use your tape measure to measure it and comes up with a accurate or close to accurate measurement of that dimension that is left off. Okay, or you can use it to verify dimension that is placed on the drawing. So if you're not sure about a particular dimension, you know what I mean, you can just use your tape measure to measure it, and you scale it with your tape measure, you measure it, and you can come up with a close description of what that dimension is. So pay all these things in mind when you're reading the plan. You know what I mean? Um, Especially if you're a builder or a contractor, these things that you should look into very very keenly in order to have your building built properly. So that's the end of it. This segment for now. I'm going to be uploading another video where I look at how you can read other parts of your drawing, your elevation, your section, your foundation, your roof framing, and your footing, and your column, and your slab detail. So for now, this is it for this video. If you like the video, hit the like button and make a comment and subscribe. Thank you.